Alright, so let's go through the 2021 paper 2, and just like with the other stuff, it's not just about the questions that's coming up on this paper, it's about looking out for the things that are going to come up in the exam and making sure that you're doing all the questions in the way that I'm doing it. Alright, so question 1, I've identified the topic straight away, so I can see this is a static electricity question. Now, when it's a static electricity question, I always know that there's 5 key things that I'm going to be looking for. So I've identified the topic of static electricity, and I know, okay, I'm just going to be looking for these 5 things. Now, I can't be bothered to write them all down, so hopefully, like in the video, I can put the slide on the side of the video or something like that, and then you can read it from there. Let me just go like this and see if I can then edit it in afterwards and see if it works, and then that'll be very, very cool. Okay, hopefully that worked. So the things I'm always looking for in the static electricity questions are there should be some kind of insulators that are rubbed together. So, and if there are, I've got to always just say the same thing: electrons are transferred due to friction. I'm looking for, is there an opportunity to say that like charges are going to repel or opposites are going to attract? I've got to remember that only electrons are going to move. So if I make any reference to any positive charges moving or protons moving, anything like that, I'm going to get 0 for the question. And then the other thing I'm looking for an opportunity to show the examiner that I know is that excess charge is going to try to find a way to get to the ground. So is there some kind of conductor or something like that in the question that I can say, okay, electrons are going to be earthed, or basically the charge is going to be neutralised. So either electrons going to the ground or electrons coming from the ground. So they're all the things that I'm looking for in all static electricity questions. So let's just have a look at the part 1 and then just see, can I say any of those things that hopefully are on the side of the screen? And it says, how can a student give the plastic strip an overall electric charge? Well, if I'm saying I want to charge something, I know straight away, well, of course that's going to be 0.1. So I know that it's got to be transfer electrons due to friction. And as soon as I'm saying that, yeah, it's a 1 mark question. I've got the mark for that. I'm making sure I'm using the keyword electrons. I'm making sure I'm using the keyword friction. And then I can make sure that I'm just saying insulators as well. So I know that the plastic strip is an insulator. So that's what also gives me the indication. But why risk it? I'm just going to say by rubbing it with another insulator. Okay, so then looking at the next part of the question is, are there any of those points that are going to be tested in this next part over here? So it says the electrical got no overall charge. So if it's got no overall charge, I know it must have the same number of protons and electrons, or the same number of positive charges and negative charges. If I'm bringing a negatively charged plastic strip to the cathode electrode, it says the gold leaf is going to bend away. So then what's going to be the reason for that? Well, let's just have a look at what's happening if I'm bringing a negative charge to the thing. Well, if I'm bringing negative charge to the cap, it means that I'm going to have a negative charge is basically going to be going down. So I can see from over here the negative charge, so this is the negative charge that's on the rod. I can see that as repelling the negative charge, which is what I expect. It's attracting the positive charge. Are any of the others saying the same thing? Well, negative and negative look like they're attracting here, so that can't be right. And it's repelling the positive, so again, that can't be right. Over here, there's nothing here, and it's repelling positive, so that definitely can't be right. This is repelling the negative, but there's nothing here. So I'm pretty happy that the answer's got to be C. And now, if you from that slide that hopefully is on the screen, it's like points 2 and 3 that they're testing here. So from even before seeing this question, I knew these things were going to be tested. Well, they've already tested 2 of them. Okay, so let's have a look at part B to the question. So it shows another gold leaf electrode giving an overall negative charge, and then the metal cap is connected to earth with a piece of wire. Now this looks like it's pretty clearly going to be points 4 and 5 now. So actually in this question, they've tested all of the things in there, because I can see the fact that it says it's a piece of wire. Well, if it's a piece of wire, that's telling me that, yeah, that's going to be a conductor, obviously. And so what's going to happen in this situation? Well, first the gold leaf was up, now the gold leaf has gone down. So the fact that the gold leaf has gone down, what is the obvious thing that I can say here is that it's now become neutral, so it's become neutralised. It'll just become neutral. Why has it become neutral? Well, it must have been discharged. And why has it been discharged? Well, first, it had loads of electrons. And now what must have happened? Well, the electrons have moved to the ground. Or I can say earth through the conductor. Now, if in the real exam, it might not test all 5 points. This is actually just quite a nice question that all of the 5 points that I said have all been tested. In the real exam that you might get, okay, it's going to be some of those points. It might not necessarily be all of them, but you know that it's always those things that you're looking for. Okay, so part C. So this is just a content one here. I've got to kind of just remember the content, but even if I couldn't, just say I'm struggling, anything like that, what can I do? So it says give two differences between a charge on P and a charge on Q. Well, even if I don't know, I can very clearly see from the picture what are the two obvious things that I can see. So this one's got arrows pointing in, whereas this one's got arrows pointing out, so it must be something to do with that. And the other obvious thing is these ones have got, this one over here has got loads of lines close together, and this one has got fewer lines and they're all further apart. So is there anything that I can say about how close the lines are? I've remembered from my content that how close the lines are, that shows the strength of the field. So I can see that object P has got a smaller charge than Q, or I could say it the other way around, that Q's got a larger charge than P, has got a smaller charge than Q. Now obviously I've got to be careful. If I'm saying that one of them is about the size of the charge, what is the other thing? It was to do with the arrow, so I can't say or point to the other one's got a bigger charge. That would be silly, that's the same thing. So now the arrow is pointing outwards, and what do I remember about what the direction of arrows mean? Well, I can't remember which one's positive, which one's negative, but what I do remember is that the arrows are telling me the direction a positive charge is going to move. So if I put a positive charge over here, that's saying that positive charge is going to move away. If I put a positive charge over here, that's telling me that positive charge is going to move towards. Well, now I should know, and from what did we say on the earlier thing as well with the points on the slide, that like charge is going to repel, opposite charge is going to attract. So if on P, this one here is attracting to there, I know that must be negative. If this one's moving away, well, that one must be positive. So now I can say that Q is positive, P is negative. And I'll just make sure that I'm saying both, because, like, again, why would I risk it? I definitely want to get the mark. Object P and Q are held near to each other, so their electric fields interact with each other. State the effect that the electric field of object Q has on object P. So this is kind of like following on from the next one. So the fact it says state means I know it, I've just got to say it. So what's the information I've got so far in this question? Well, I've just worked out that Q is positive and P is negative. If one's positive and the other one is negative, then what's the thing that I can say for that? And I just know that, well, they're opposite charges, so it's going to attract. So the effect that object Q has on object P, so I can say object Q will attract object P. And then, yeah, I'm definitely going to get the marks from there. Okay, so question number 2. So the topic doesn't really matter here because straight away I've seen it's a graph. So when it's a graph, what are the things that I'm always trying to do? I know I'm going to be looking at axes to see if there's any conversions. I'm going to be looking to see, I'm always going to be looking to take numbers somewhere from the graph, take readings from the graph, and I should know how to describe the relationship of a graph, straight line is the curve, all of that kind of thing. Okay, so now that I've got in my head the possible questions that can come up here, well, let's just have a look at what the first question is. Describe the relationship. So when it's to describe the relationship, particularly with a graph, it's always the same thing. As the something increases, the something increases, decreases, stays the same. And then I've got to say, is it proportional, is it non-linear? So I can see that the line is going up. So that means I can say as V increases, I increases. Now obviously you're going to write it in full in the exam, you're not going to abbreviate like I am. And then so that's going to be probably my first mark. And then is it a straight line through the origin? No, it isn't, so therefore it's not directly proportional. So it is through the origin, but it's not a straight line, so it's not directly proportional. So I'm just going to say it's non-linear. The fact that it's a curve, any curve that I see, I'm just going to say it's non-linear. And then if I want to be extra fancy, I can just give a bit of extra information that here the gradient was steep, there the gradient is shallow, so therefore the gradient is decreasing. But I don't really need to say that one, it's just if I want to show off. Really, I know I'm going to get the mark for these 2 points over here. All right, so what's coming up next? So it says use the values to complete the table. So basically I was looking out for this at the start. I know I'm going to have to take readings from a graph at some point, and I just need to take the readings at point P and point Q. So let's just go back to the graph and draw a line from point P. So I can see at point P the voltage is 1, and the current is 20 milliamps. I'm being careful with the units. Do they match the ones in the table? So that's volts, that's milliamps. So yeah, they do. But the point is that I was looking for it and making sure that I'm not tricked, because they might do this in the real exam. So at point P, the voltage was 1 and the current was 20. So I'm writing 1 and 20 in there, and I'm just going to do the same for point Q. So at point Q, I'm going to go down there, and it looks like 3.5. Obviously use a ruler in the exam, and I'm going to go across there, and it looks like it's closer to the top than it is to the bottom, so I can say 43. So that's going to be 3.5 here, and that's going to be 43. Now with these ones, if you get it, 43. Now if you get it slightly wrong, they always have a little bit of tolerance in there, and that's why it's important just to make sure that you're showing the lines, and then you'll be okay with that. So the next one's pretty nice, a formula question. As long as I do everything that I'm supposed to be doing, nothing can go wrong here. So the first thing that I do is check the units, and I can see that that is got a prefix on there. This one hasn't. So I know I'm going to have to do a conversion. So I'll just do that conversion straight away. So 51 times 10 to the minus 3. And now it's in my own writing. I don't need to panic about, oh, I'm going to get it wrong later. So it says calculate the resistance, and they've been nice enough to give the formula here. So I'm just going to fill it in. So I'm looking for resistance, I'll put in R first. What is V? It told me V was 4.5. What was current? It was 51 times 10 to the minus 3. Now remember what we said for these kind of questions here, that make sure you're using the fraction button on your calculator. So use the one that looks like this, because otherwise you might mess up the order of operation if you try to type in times 10 to the power of whatever. So the other thing you can do, if you don't want to use that, you can put it in brackets, but just make sure you don't mess up on the calculator basically. And the way that you do it is just use the fraction button that looks like that. And then I'm going to type this in the calculator, and I'm going to type the full number in from the calculator. So 4.5 divided by 51 times 10 to the minus 3. And then I can see that it's saying 88.235294 blah blah blah, and then I'm just going to round it to two significant figures because that's my default position unless it says otherwise, and that's 88. So the resistance is going to be 88 over here, and I'm happy that I have got full marks there. Okay, so this next question is an explain question over here. So I know I'm going to try to go law, principle, or formula, state the obvious, keywords linked to the question, those things that I should be doing in there. So what's the key thing that stands out to me in this question? It's saying why the resistance on the filament lamp changes as the voltage increases. So the first thing that stood out is that it's saying the resistance changes. Now I know that changes isn't good enough, because just like when I'm giving an answer, I can't say oh, it changes, I've got to say increase or decreases. So hopefully I've done my revision and I just know what's going to happen to resistance when the voltage increases, and I know that the resistance increases. Now, if I didn't know that, it's okay, because I don't straight away have to go to that thing that I know. I'm doing it here because I want to get the mark, but I can still figure some stuff out. So even if I don't know the principle that as the voltage is going to increase, the resistance is going to increase, I can just go for the state the obvious. So what are the things that I do know? So it's saying that the voltage increases. So if the voltage increases, well, let me just have a look at the graph and see what happens, even if I didn't know from my vision. Well, when the voltage is increasing, I can see from the graph that the current's increasing, and I set it over here as well. So I'm just going to say as well, okay, so when V increases, I increases. Now, why does that matter? I don't really know. Well, if I increases, I know that I is something to do with the electrons moving. So if I increases, there's going to be more electrons moving. Now, I can't say there are electrons moving because they're moving anyway. So I can say electrons are moving faster or electrons are moving more, some kind of comparative word in there. So the electrons start moving faster or start moving more, they have more energy, anything like that. So now if they are starting to move more or move faster or have more energy, well, what actually happens inside the wire? Well, now I can remember, oh, actually, yeah, when electrons were moving, there were more collisions between electrons and the ions, or the ionic lattice, or the lattice in there. So I'm just going to say that. Now, what do I know about collisions? Oh, yeah, when there's collisions, there's going to be friction, and whenever there's friction, there's going to be heat. So there's going to be heat due to friction. And when there's heat due to friction, well, I know the resistance increases because the kinetic energy of the kinetic energy of the ions in the lattice will increase. Therefore, they're just basically going to get in the way. So therefore, there's going to be more friction. and like even more collisions. So I am happy that I'm getting that right. Okay, so what's the topic of this one? I can see that it's saying particles, and it's asking for two differences. So this, I hope, is a pretty straightforward question, because when it says two and it says between solid and liquid, I know the things that they always care that you've got to talk about: the position of the particles and the movement of the particles. So what do I know about the position of the particles in a solid? Well, I know the particles in a solid are close together, regular arrangement. So I'm making sure that I'm saying in solid, close together with regular arrangement. But because it's asking for difference, I obviously can't just talk about one of them. I've got to make sure I'm using the comparative terms. I've got to say whereas in a liquid, and then what do I know about the particles in a liquid? I know they're randomly arranged. And again, I'm just abbreviating it, but you'd have to write in full, obviously. Okay, so then I've talked about the position of them. That one's 1 mark, and then the other one's going to be the movement. What do you know about the particles in a solid? So again, I'm not going to write the full thing. Particles in a solid, I've got to use the key term vibrate about fixed positions. It's always the same thing. Whereas positions, whereas particles in liquid are free to move. They've got more kinetic energy. That's meant to be an L. I'll just write liquid. Move more kinetic energy, and like we've said in the past, I'm trying to look for an excuse to use energy terms in any question that I can do. So I've done that. And then the next one is it's a formula question. So what I always just do the same thing, and I'm pretty sure that this is going to be 3 marks, and so I'm quite happy with this. So what do I do first? Look for conversion. So that says meters, that's fine. Meters is fine. Meters is fine. And then once I've done that, I need to try to identify the formula. Well, this is quite nice because they've given it to me, so I don't even need to do any work there. It says calculate the mass of the concrete block. So M is accounted for, that's fine. Density is accounted for. Volume isn't accounted for because they don't give me a volume. But what do they do? They give me the 3 lengths of the 3 different dimensions of the concrete. So I'm going to show the examiner clearly. I'm working out the volume first. So volume equals 1.5 times 1 times 0.2. I'm going to put that in my calculator, and the answer that I'm getting is 0.3, and I'll still put the unit meters cubed. Well, now that I've got that, what happened there? Doesn't matter. Now that I've got that, I can just put it into the other equation. So I'm going to write down the other equation: mass equals density times volume. I'm looking for mass, so I write down M first. The density it gives me is 2,100. The volume it gives me is 0.3. I'm going to put that into my calculator, and I'm going to get 630, and that's fine. So 2 significant figures. I'm going to write the answer 2 significant figures there, and I'm happy that that's the right answer. So the next part of this question is essentially just like recall or content stuff. So 2 practical ways to reduce heat loss from the shed. Well, first, I know that heat is transferred by conduction, convection, and radiation. So if I'm really stuck and I can't remember any of the stuff I've done from my revision, okay, it's probably going to be something to do with those, or I can use that to help me problem solve. Well, firstly, if we're talking about radiation and we're talking about heat loss, one thing that I do remember, I'm going to say this one first because this is the most popular one that comes up in different types of questions in different contexts as well, is about radiation. Basically, what color is the best at reflecting heat and what color is the best at absorbing heat. Well, if I want to reduce heat loss, I want to make sure I'm reflecting the heat back to where it came from. So if I want to reflect the heat back to where it came from, I'm going to use silver or white, basically, so foil or something like that. So I can say use white paint, or talk about putting foil around there or something like that. And just to be on the safe side, even though it doesn't say explain, it says state, I'm not going to gain anything by missing out some information. I might as well put it in there. So use white paint or foil to reduce heat loss by radiation. Heat loss by radiation. Okay, and then what else, if I'm talking about like conduction or convection or anything like that, okay, so on the main things that I can be using are like double glazed windows or draft excluders or extra insulation or anything like that. So either of those are going to be fine. So insulation, draft excluder, and I'm not going to write all of them, but any of those things are going to be fine. Double glazed windows, I said as well. Okay, so then the next one, again, it's just content stuff because it's not even like really a formula. It just says calculate, even though it does say calculate. Because we're talking about Kelvin scale, they're actually being quite nice here, because a lot of the times when they're testing you on this in paper 2, they kind of like sneak it in there and don't tell you it's conversion. Well, this is just a 1 mark question saying do the conversion. So what do I know about the Kelvin scale? Well, the thing that I know is 0 degrees C is the same as 273 degrees Kelvin. So if that's the case, if I want to get from degrees to Kelvin, what have I done in this case to get from 0 to 273? Well, obviously I've had to add 273. Well, now I know that, I can apply it to everything. So I'm just going to show my working as well. So I'm going to say -4 plus 273, put that in my calculator. I'm not going to gain anything by doing it in my head. And what it's saying in my calculator, it says 269, so I'm going to write that down. And to be fair, because I'm showing the examiners this number, in this one maybe I would just keep it as 3 significant figures, and I'm happy that I've got this answer right as well. Okay, so what's the command word I'm seeing here? The command word is calculate, which means I am very, very happy indeed, because I can just do the same standard boring stuff and I'm going to get full marks for it. So I'm going to check for my conversions. Meters squared is fine, newtons is fine, that's okay. Now I've got to identify the formula. So this is one where I've got to do a little bit more work. Well, what am I looking for? I'm looking for pressure. So I'm definitely going to need a formula P in there. It's giving me the area, so my formula it should have A in there as well, and it's giving me the force, so the formula is going to have F in there. Now, if I can't remember this formula, obviously just look at the formula sheet, and then what is the thing with those 3 things in there? I know it's pressure equals force over area, so I'm going to write down the formula properly. Okay, now what am I looking for? I'm looking for pressure, so I'll write down P first. Have I got the force? Yeah, I have. It's 2,400. Have I got the area? Yeah, I have. It's 0.8. Now, like always, I'm going to make sure that I put this in my calculator, and then put the full number of my calculator first. So 2,400 divided by 0.8, and that gives me 3,000, and that's the full number of my calculator. And also, if I was going to do it 2 significant figures, it's still 3,000, so I'm going to write down 3,000 here. The units is the proper unit, so there's no trick there, but can you see how I've just made sure that I've looked out for the popular tricks that come up? So I looked for the units first, I looked for the units at the end. Everything's fine here, there's no tricks, and it was a 3-mark question, which is kind of what I'd expect from this question, having to identify the formula. So I'm happy. Okay, so what's the command word for the next question is explain, and explain how the pressure on the bottom of the tank changes when more water is added to the tank. So if I can, with any explain question, I'm going to go law, principle, or formula, and ideally, is there a formula first? For this question, is there a formula about pressure? Well, what's the thing that it says? It says more water is added to the tank. So if more water is added in, what has happened to the thing? Well, it's getting deeper. So there is a formula with pressure and depth. So the first thing that I'm going to do is write the formula. Pressure equals depth times density. That's the times, not proportionality. Times density times G. Okay, so is the density of water constant? Yeah, it is. Is G constant? Yeah, it is. Therefore, I can say pressure is proportional to depth. And if I'm doing A-level, I have to say, because these 2 things are constant. Because I'm doing GCSE, I don't have to, but it's not going to hurt me to say it. So I'm going to just say it in there, because rho and G are constant. And if you are doing A-level next year, then obviously just get into the good habits now, and it's better for you. So that's meant to be a proportionality, pressure, proportional depth. Okay, so now I'm just going to try to link this to the question over here. So when more water is added, so more water means more depth, which means more pressure, therefore more pressure. Now, I'm happy that this is going to be the full marks of the question, because I've done everything that I can. But like we're always saying, I mean, it's not going to hurt me to give any extra information. So can I think of anything extra that I can say for it? So more water means more depth, means more pressure, and I've given this formula over here. But because they've just asked me to say something about pressure and force and stuff like that, I might as well just say something. Okay, is it something to do with that as well? So I can say there's going to be more force from the water above it. And I don't really need to say this if I've said all the other stuff. I'm still going to get marks for all of this, but it's never going to hurt me to just give it extra information. If I know it, I might as well say it. Okay, a 1 mark question here, and this is just a content recall question. So when it says the direction of the force exerted by the water, what is the thing that, what's the content thing that they need me to remember? And the specification, the content stuff for triple, so this isn't combined, is you have to remember that pressure in fluids is always at a right angle to the surface. So if the surface is, you can see where the surface X is, so here's the surface. So the pressure at the right angle is going to be that. Now, I've got the mark for doing this, that's going to be fine. But just in case I think I'm crap at drawing or something like that, or it might not be very clear, I'm just going to just state the thing that I know, just in case I get that wrong. I might as well give the examiner another chance to give me the marks. I'm just going to also say pressure from fluid is always at right angles to surface. And then even if my drawing is a little bit rubbish, a little bit wonky, the examiner knows that I know what they were looking for, and I'm always looking for the opportunity just to show that, yeah, I know what you want me to say. I'm just going to say it, and you can give me the mark. Thank you very much. Okay, so what's the first thing that I see about this question? Well, obviously there's a graph in there. So as soon as it's a graph, I'm always got that same mentality that I'm not going to be happy until I've taken readings from the graph or drawn on the graph and shown the examiner that I know how to do that. So I'm looking for every opportunity that I can to do that. So let's have a look at what the question says now. So the aeroplane is going to descend from 6,000 to 2,000, use the graph to find a change in atmospheric pressure. Okay, so first it's telling me straight away I've got my opportunity to use the graph, so I'm obviously going to draw on it here. And then the other word that stands out to me here is change. Now, because it's saying atmospheric pressure, I'm thinking, am I going to have to do a calculation? Am I going to do a formula that says pressure equals, or is this something that I can just read from the graph? Well, let's have a look at the axis. It says height above sea level, atmospheric pressure. So that means that obviously I can just read this from the graph. Now, before I start this question properly, then let's just take it a unit. So this is meters over here. This is kilopascals. So I've just got to make sure I'm being careful with my units. And we said this for an earlier question before as well. Well, those units, kilopascals, match these ones. So there's not really a trick in there. So that's okay. But as long as I've checked for it, because in a future question, there might be a trick. Okay, so what do I need to do? It descends from 6,000 to 2,000 meters. So it's just the standard thing that I'm always going to do. So I draw a line from 6,000 up to my the line on the graph, and then go across from here. And I can see that's like halfway between those two squares. So what does it say on there? So at 6,000, I know it's 50 kilopascals. So then I'm going to just make sure that I'm saying that at 6,000 meters, pressure equals 50 kilopascals. Because remember, even if I get something wrong, there's 2 marks in this question. So I might be able to get error carried forward or something like that. The next one is 2,000 meters. So what's happening at 2,000 meters? So zoom in again. Let's have a look. So draw it to the line. Now this is quite nice because it's on a nice one. So it comes across there, and that's going to be 80. So at 2,000 meters, pressure equals 80 kilopascals. So it went from 6,000 to 2,000. So it went from a pressure of 50 to a pressure of 80. So what's going to be the change? Change is always something, take away something else. So the change is going to be 80 kilopascals minus 50 kilopascals. So then I know the answer. I'm going to put it in my calculator, and I get the answer is 30 kilopascals. And again, like we said, I've already checked the unit, and I know that unit's okay, so I can just leave that as 30. It's already too. I don't need to round it to any less than that. That's okay. Okay. Okay, so the next one says suggest. There's the command word here. Now, suggest is essentially explain. So I'm going to try to do the same thing that I can for explain questions, which is there a law, principle, or formula I can use? And then state the obvious keywords and try to link it to the question. So if it's in atmospheric pressure and it says greater at 2,000 meters than 6,000 meters, well, I'm obviously going to need a form of pressure in there if there's a formula that I can think of, and it must be something to do with when it's saying 2,000 meters, 6,000 meters. Well, what is that to do with? That's the depth of the atmosphere. So is there a formula of pressure and depth in there? Yeah, there is. There's a formula that says pressure equals depth times density times G. So I'm going to write that formula first. Now, I still might not know the answer here, but this question is very nice because it tells me the atmospheric pressure is greater at 2,000 meters. So if it's telling me the thing is greater, I know that because I know about proportionality, I know that either it's because the depth is going to be greater, either because the density is going to be greater, or because the G is going to be greater. Well, let's have a look about any of those things that I know. So at 2,000 meters, if I'm 2,000 meters above the Earth, so here's the Earth over here, if I'm 2,000 meters above the Earth, compared to if I'm 6,000 meters above the Earth, where's the depth greater? It's a bit confusing maybe because the number is smaller, but if you have a look, well, this is deeper below the top of the atmosphere than this one. So I can say at 2,000 meters, depth is greater. And then I can say, therefore, pressure is greater. Well, that's probably enough to get me the mark because it's only a 1 mark question. But just to be safe, I should also, and this is just something that you should know anyway, that in the atmosphere, if we're talking about air or any gases, as the depth increases, the density also increases. So density greater at 2,000 meters as well, then 6,000 meters. In liquids, the density, this is on your specification, density, you're taking it as being constant all the way through. But in gases, the deeper you are, which means the closer you are to the Earth's surface, the denser the denser the fluid is. And that is, again, they might test it in a different way, but you just need to make sure you know that, make sure that you're looking out for that. So we've got another explain question. Now this is basically going to be the exact same process that we've just been through with the previous question. Because it says explain, I'm going to do the same thing, law, principle, formula. Is there any state the obvious, keywords, and can I link it to the question afterwards? If I can do all those things, I'm definitely sorted. So is there a formula? Well, what do I need a formula for? It says explain why exerts a different pressure. So is there a formula with pressure in there? And then it says when standing up compared to lying down. Now they've actually made this even easier for me by drawing the pictures because I can see the difference between lying down and standing up. What's the obvious difference, the state the obvious that they're trying to make me say? So even if I don't know the law, principle, formula, what's the obvious thing that I can say from that? Well, lying down means there's a greater area. And I'm just going to abbreviate, means greater area. Okay, so if there's a greater area when he's lying down, is there a formula that's got pressure and area in there? Oh yeah, there is. Pressure equals force over area. So I'm going to write pressure, pressure equals force over area. Again, obviously you've got to write in full words. So I've done the law, principle, formula. Okay, so have I used keywords? Yeah, I've said area, I've said force, I've said pressure, so the keywords are sorted. Now how am I going to link it to the question? Well, from this, I know that pressure is inversely proportional to area, and we've said that you're always going to get these kind of relationships that you're going to need to be using. And I'm also going to say here, just to get into the good habit and get into practice of it, that the force is going to be constant. Well, is the force constant? What is the force? It's his weight. So the force is constant because his weight is constant, and that is the force. Therefore, smaller area means greater pressure. Now they said a different pressure. As we've always said before, that's not good enough because you need to be clear on, like I've just said here, this is meant to be arrow, greater pressure. So that's the situation. Smaller area means greater pressure. So when lying down, or when standing up, he will have, because that's the way that I've done it before. So when standing up, there's a smaller area, therefore there's going to be a greater pressure. All right, so this next one might seem like it's a pretty difficult question. It seems like pretty obscure kind of thing that we've got, but if we just break it down into how we always break down questions, I can't really go wrong. So let's have a look. So it's obviously about magnets and it's about plotting compasses. So even before I start the question, well, what do I know about plotting compasses? I know they always point to the south pole of a bar magnet. They always follow the field from north to south. So I know that plotting compasses are always going to point to the south pole. Now let's have a look at what other information that I've got. So that's the law, principle, they're going to be testing me on. What information do I have? It says that there's two magnets and the pole of one of them is a few centimeters away from the pole of the other one. So I know that all of these arrows over here must be pointing towards the south pole of a magnet. Well, I've got some pointing this way, I've got some pointing that way, and if they're a few centimeters apart, that suggests that those magnets are probably going to be here. So there's one there, so those are pointing to the south pole of this one. They're going along that field. There's probably going to be one there. Hopefully your rectangle's a bit nicer than mine. And then it also says, well, even if it didn't say this, I should know I've got to label it because I'm showing the examiner I know the arrows point to the south pole, so that one would be south. and that one should be south. And then this one, obviously that's going to be north, and then that's going to be north. I'm happy now I've got the 2 marks. I've drawn them in the correct position. I've labelled them. It'll probably be 1 mark for drawing in position, 1 mark for labelling it. So that's 2 marks there. Okay, so this is one about describing an investigation. So whenever there's a describe an investigation one, I'm always going to try to do the same thing for all of them. So I'm going to use a formula if there is one, and then I'm going to go for equipment, the measuring equipment. I'm going to go for the method, so anything reasonable at any kind of detail. And then if it's relevant, I'm going to say repeat, well, I should always say repeat and take an average anyway, and plot a graph if it's relevant. Okay, now this one is a little bit of a weird one because it's not really, you're not trying to find an investigation as to how does one thing affect another thing. So maybe this one's not really relevant. Definitely plot a graph's not going to be relevant in this one because you're not looking at how 2 variables affect each other. But let's just have a look at the other stuff. So the first rule is always formula if there is one. Is there a formula? Again, no. So I know that this thing's not going to be relevant, this thing's not really going to be relevant, and this thing's not going to really be relevant. So I'm just got to think, what's the equipment I'm going to be using? Well, it says using a plotting compass, and maybe I'm not going to get the mark for that. I'm just going to say that, and obviously I'm going to need a magnet as well. So I'm just going to say put the compass near the magnet. And now it's just the detail. Can I remember what I did in this experiment when I've done it in school or when I've learned about it in school? So I just look at which way the arrow is pointing. And then you mark the mark a little X there, and then you just move the compass to that field, to that point, sorry, and then you just keep on repeating that same thing. So you're going to have loads of X's. And then after you've done that, you're just going to join up all of those points. So you're going to end up with something like this. If that's the magnet, and that's north and south, if I put the compass here, I know that that compass is going to kind of point in that direction. So I'm going to mark an X there. Then I put the compass here and it's going to point in that direction. So I put X here. And I'm going to end up with loads of X's that go like this. And then I'm just going to do the same thing on the other side. I'm going to end up with those loads of X's. And then you're just going to join up all the points. And I should end up with fields. So these are, obviously I've plotted loads more X's. And I'm going to end up with a field that looks like this. And obviously all of these would just have X's all over them because I spent time plotting that. Okay, so that's going to be the 3 marks for this one, really. So here's a question that's definitely going to come up in the exam. It comes up every year in either paper 1 or paper 2, and that is the fact that it's an unfamiliar equation, and it's an unfamiliar equation with a constant. So this one is kind of breaking it down for me a little bit more because it's actually saying just calculate the value of the constant. But if it doesn't do that, you just know whenever there's some kind of unfamiliar formula with a constant, just make sure you work out the constant, and then the question might ask you to do some other stuff with it. But this one's a little bit simpler. It doesn't ask you to do that. Now, there's a couple of ways that you can do this question because it says about 4 centimeters apart. So I've identified that this is the incorrect units, it's in centimeters. So if I want to do it the proper way and just be consistent all the way, I'm going to convert that. So I know that 4 centimeters is 4 times 10 to the minus 2 meters. I'm not doing anything fancy. I'm just writing the number, writing the conversion, job done. And then the force it's given me is 1.2 newtons. So basically I can just put this into a formula. So I'm going to write down F equals K over D squared. I'm looking for K, so I'm going to write down K first. F, it's already told me is 1.2, so I'm going to write 1.2 where the F is. I'm going to write, and I've done the conversion up here so I don't get tricked, 4 times 10 to the minus 2. What do I need to be careful about here? Very, very often when there's an unfamiliar equation, they put a square in there because they know that students forget. So I'm not going to forget because I'm waiting for that. And I'm going to put that in there. So I'll rearrange this to say K equals 1.2 times 4 times 10 to the minus 2. And I'm going to just put the numbers in my calculator, write the full answer. So it's like 0.00192. And then I'm going to round to 2 significant figures. So 2 significant figures here would be 0.00. So these noughts don't count significant figures. That's the first significant figure. And now that's the second significant figure. Okay, that's fine. I've rounded that properly. So how am I going to get the unit from there? Well, in order to get k, I had to do f times d squared. What was the unit I used for f? It was newtons. What was the unit I used for d squared? Well, for d, I had it in meters. Therefore, that's going to be meters squared. So newtons times meters squared, the unit is going to have to be Newton meters squared, and that is job done. Now, I said there's a couple of ways to do it. With these questions, when you're working out the constant for yourself, and it asks you that, it gives you the opportunity that you can work out the unit. Well, if I'm choosing to work out the unit, I can technically just leave it in centimeters if I wanted. So if you're confident with your maths and you wanted to leave it in centimeters, you can do the exact same thing that we said before. So write the formula first. F is equal to 1. I'll put the K first. F is equal to 1.2. This time D is 4 centimeters. So rather than saying 10 to the minus, I'm just going to say 4. I've still got to square it. When I rearrange that, I get K is equal to 19.2. So 2 significant figures going to be 19. Now this time to get the unit, it was still K equals F times D squared. But this time F was still in newtons, but D was in centimeters. So that's going to be centimeters squared. So it's going to be Newton centimeters squared. Either way, I'm going to get full marks for this question. It just depends on how you want to do it. All right, so the next one is just a 1 mark question, and it's just, normally 1 mark questions is just content. It's just stuff that I need to know, and the fact that it says state is showing me, yeah, it's just the content stuff. I need to make sure I've done my revision. So what's the information that it's giving me? The same distance apart, so that's something that's pretty important. And then it says now the N pole is facing the S pole, so rather the S is facing each other, it's the N facing the S. Now it says state how the force is going to compare. Well, there's 2 pieces of information that they've given me. So even though it's a 1 mark question, because they said same distance, I'm suspicious about that. And they also said now it's N rather than S. So that's changed. So the same distance, what does that mean? Well, I know the magnitude of the force is going to be the same. That's why they've bothered telling me about the same distance. And why have they told me that it's swapped from north to south? Well, it must be because now the force is in opposite direction. Now, even though this is just a content recall thing, even if I couldn't remember anything like that, I'm still breaking down that question to be, what am I suspicious about? Why have they told me same distance? Why have they told me north and south? So I know, okay, that's giving me a clue now in order to get that right. That's what you want to be doing with the more difficult questions as well. That what is the clue that they're giving me, and just make sure that I'm using that. And then, yeah, that's going to be fun. So this next question is, if you're doing combined, it doesn't matter. But if you're doing triple, it's on the triple spec. So what does I can see it's about pivots, moments, and all that. So I know I'm going to say about those things. So it's a state, which means I just know I just need to know it and write it down again. And what's the key piece of information it's telling me? It's telling me that it's in equilibrium. So basically, what it's asking me about is about the 2 moments, and what do I know about moments when they're in equilibrium? So this keyword here, equilibrium. And I just know the same thing that I'm going to make sure that I write down all the time. So the sum of the clockwise moments is equal to the sum of the anti-clockwise moments about a pivot. And it's already told me it's in equilibrium, but again, it's not going to hurt me just to say it, because the whole principle of moments is this. So if there's any question about the principle of moments, this is what you say. It's always the same thing, equilibrium. Just say that, and then job done. All right, so what's the command word first of all in this question? The command word is calculate, so I know that I'm going to have to use a formula. Is there anything that stands out to me? Well, it says about a DC power supply. Maybe there's something about that. I'm a bit suspicious about that. These things are in centimeters. So I know I'm probably going to have to do some conversions there, or if I'm not confident with maths, I'm just always going to do my conversions. And then I'll show you when we're doing this question about why maybe you didn't need to in this particular situation, but it's better to be consistent. And if you're not sure, just always do the conversions. So what's the formula for this one over here? Well, I've just said the principle of moments earlier, and this is leading on to it. So I know it must be the sum of the clockwise moments. So that's the sum symbol sigma. Sum of the clockwise moments is equal to the sum of the anti-clockwise moments. Okay, so what are the clockwise moments and anti-clockwise moments? So basically, I know that they're going to be acting in different ways. So here's the pivot over here, that must be going down that way. That must be going down that way. So what are the different moments? Well, I know that um, the force times the distance on this side must be the force times the distance on the other side. And what am I trying to find out? I'm trying to find out that force between the magnet and the coil. So I'm going to put the F down there. What's the distance? The distance is 12 times 10 to the minus 2 equals to what's that force over here? It's 0.05 times the distance, which is 8.4 times 10 to the minus 2. Now, what I just said is better to do the conversions if you're not confident with your maths. But if you were confident with your maths, you might even realise beforehand, well, that times 10 to the minus 2 cancels with that one. So you didn't actually need to do it. But it's always better to play it safe. And if you're unsure, if there's any doubt in your mind, it's not going to hurt you to do it. You might as well just do it rather than risk it, rather than risk losing the marks. So now F times 12 equals 0.050 times 8.4. If you're good at your math, you can just do this in one stage, but we've said that some people might not be confident. So I can just simplify the right hand side even more. So I can say F times 12 equals what is 0.050 times 8.4. And I'll just put that in the calculator and I can find out the answer is 0.42. Now that I've done that, this might seem a little bit easier to rearrange. So I'm saying F equals 0.42 divided by 12. And therefore, again, put it in the calculator. So when I'm going to write up here instead, F is equal to 0.035. That's already two significant figures, so I don't need to round any more than that. So I can just put 0.035 in here, because remember, if it's after a decimal point, the first naught doesn't count as a significant figure, but all the subsequent noughts do. As in, if it comes after a number that isn't naught, then other noughts will count as a significant figure as well. Okay, so yeah, I'm happy I've got this one right. Okay, so let's have a look at the next one. Now, always, I'm just going to try to identify what type of question it is first. And it says, how could a student develop the investigation? So I've identified, yeah, I know this is an investigation type of question. So how am I going to do this? I'll write it here first, but I'm going to have to worry about it after to have room to write. So there's going to be formula if there is one. Is there some kind of formula I can use? I'm going to say measuring equipment. I'm going to try to use a method. So I'm going to try to say, change the something, measure the something if I can. I'm going to see if I can, well, I'm always going to say repeat and take an average. And then I'm going to say plot a graph. If it looks like, I can say plot a graph of something against something. Okay, so these are the things that I'm going to have to do. If you need to write down somewhere, then write it down. But hopefully you know it by now because we've done quite a lot of these. So I'll just rub that out so I've got room to write my answer. Okay, so the first thing is that, I mean, is there a formula that I'm going to kind of use in this one? So if it's talking about the size of the force between the magnet and the coil, well, I've just worked a question out earlier, so I know that it's probably this formula that I'm going to have to use about the clockwise moment and anti-clockwise moment. So I'm just going to basically write that one down first. So the formula I'm going to use is the sum of the clockwise moment, and obviously you have to write it in full, I keep on saying that, equals the sum of the anti-clockwise moment. How am I going to get the moments? I know that moment equals force times distance, distance from the pivot. Again, I should be writing that down properly. Okay, so probably I've got a mark for this. Now let's have a look at the next one, so the measuring equipment. What measuring equipment I'm going to have to use? So I know the weight, it says it's 0.050 newtons, but I can still say that I'm gonna like measure it using a mass balance. So measure weight using mass balance, and then I'll have to do W equals M times G. So weight equals mass times gravity, even though it tells me, so I might not get the mark for that, but it always doesn't hurt to say it. Okay, what else am I gonna have to measure? So it says force times distance, so I'm gonna have to measure distance using a ruler or a meter ruler. I can just say ruler in this one because the distances are quite small. I don't necessarily need a meter ruler. Okay, what else am I going to have to do? So is there anything else I need to measure? It says directly proportional to the size of the current. Well, yeah, so I'm going to have to measure the current using an ammeter. Now, I might have already picked up most of the marks with a 4-mark question here, even if I get the next part wrong, which is the method. So in the method, I'm always going to try to say vary the something, measure the something. So what am I going to vary here? Well, it says the size of the current. So I'm going to say vary the current what am I going to try to measure? Well, I've got to try to measure the force. Can I measure the force directly? Maybe not, but I can still measure the force anyway. Well, now how am I going to get the force? Actually, I'm going to get it like this. So how am I going to get the force? So I'm going to have to say something about making this thing balance again. So by moving the 0.050 Newton weight and using the sum of the clock and using moment equals force times distance and sum of the clockwise moment equals sum of the anti-clockwise moment. So basically when I move it, I can make it balance and then just do this exact same thing that I was doing. And I think I've written enough detail for that the examiner knows what I'm talking about. There's a word that I've missed out though, because I just said move it. I think I said it when I was doing, but I haven't written it down. The word is equilibrium. So I've got to move the weight until the system is in equilibrium. Because remember, we've always got to make sure we're trying to jam keywords in there if we can. Okay. Now, can I say, sorry, I've already said change to something, measure to something. How many times am I going to do that? I'm just going to say, I don't know, get 7 readings maybe. Okay, then I'm going to repeat and take an average. Is this something that I can say, plot a graph of something against something? Yeah, it is. Where can I write? I can maybe like go here. Okay. So plot graph of I against F, because they're the things that I'm looking at. Now, is there something else that it says here? It says, is it directly proportional? So I've got to show the examiner that I know what is meant by directly proportional. So if they are directly proportional, what do I expect the graph to look like? Well, the graph should be a straight line through the origin. And that's something that we've said in like proportionality questions as well. Now I'm pretty happy that I have got 4 marks for this. I've done basically everything that I need to do in an investigation. Okay, so what's the key piece of information they've given me here? What's the obvious thing that they're trying to tell me? Reverses the direction. So if they're trying to reverse the direction of the current in the coil, well, what's going to happen with the force? Well, first the force was coming down. So what are they trying to make me say? The force is going to be coming up now. So I know that the force from the coil is now going up. So if I just look at the diagram, first this force was down and that force was down, therefore it balanced each other out. Well, if this force now goes up and that force is down, they're not going to balance each other out. So how can I link this to the question, how am I going to make it balance? Well, I'd have to move that weight over here. And now I've got a force. So this moment over here, if this was going down, this would be the anti-clockwise moment, and then that would be the clockwise moment to balance out. So that would be fine. So I just have to say that. So I'm going to move the weight to the other side of the pivot and just make sure that I'm putting keywords in there if I can, so that it provides, and the keyword that I've got to put in there is about moment, so it provides opposite moment. Okay, now have I got 4 marks for this question? Yeah, definitely. I've identified the main thing that they were saying. I've said what they want me to associate with it, and then I've linked it to the question. I've definitely got 4 marks here. So what's standing out to me, the next one, obviously there's a graph. So I'm always in the same thing with a graph question. I'm not going to be happy until I've taken readings from that graph at some point in this question. Okay, so now let's have a look at what we're doing. So I looked at axes, meters is fine. And what's on the other one? Distance. It hasn't given me any units, so that's okay. It's probably not going to be relevant then if they haven't given it to me. So let's have a look at what the question says now. So it says, what's the overall change in gravitational potential energy? Well, what do I know about that? I know GPE equals mgh. So the information there I can get from the graph, well, there's nothing about mass or nothing about g on there, which I should know is 10 anyway. The only thing is about height. So it's obviously got to be related to the height. And if it says biggest change in GPE, it's obviously going to be the biggest change in height. So let's just have a look at the different situations. So from P to Q, I've changed by 20 because it's gone from 0 to 20. From Q to R, it's going from 20 to 35, so I've changed by 15. And from R to S, I've gone from 35 to 10, so I've changed by 25. And now, because it's just asking about the overall change, it doesn't matter about bigger or smaller. So the biggest one is obviously 25. So the answer has got to be between R and S. So this next one here, then, what is it? What's the command word? It says calculate. So I'm pretty happy with this. That it's probably going to be a nice standard question, but I've still got to go through the process and make sure I don't drop. I'm not going to like get myself in a false sense of security. I've still got to go through the main process that I'm doing. So calculate the amount of work done against gravity when a cyclist travels from point B to point Q in the journey. Now, I've not really taken readings from the graph in the first part of it, so probably I'm going to have to take reading from the graph here. Okay, you might think a difference 20, 50, whatever it is, taking some readings, but I'm not really like drawing on the graph and stuff yet. So maybe I'm going to have to do it here, or maybe there's a further question where I'm going to have to do it. Well, let's see. So because I'm looking for total amount of work done against gravity when a cyclist travels from point P to point Q, well, what information have I got from the graph? I'm looking for a form with work done. I'm looking for something with height because I've got height on the graph. And let's just have a look here. It says distance along road. Well, they've not actually given me any scale here, so that's useless to me. I know it can't be anything to do with the distance. So I'm going to need to think of a formula with work done and height in there, and I can't think of one, so I'm going to look at my formula sheet and I can't even find one. So I'm finding this pretty difficult, or I'm stuck. What am I supposed to do? Well, I've remembered that the trick that examiners do, that work done just means energy, because sometimes they'll say energy instead of work done, sometimes they say work done instead of energy because they'll try to trick you. Well, luckily, I've remembered that work done means energy. I'm looking out for that. So instead of saying work done because I couldn't find the formula, is there a formula with energy and height? Oh yeah, there is. Look, I've just been using it over here. So I'm going to say GPE equals mgh. Now, what am I looking for? The work done, obviously, against gravity. So I'm going to put GPE in first. That's what I'm looking for. Have I got the mass? No, I haven't. Have I got G? I should know G is 10. Well, actually, it tells me here that the weight of one cyclist and bicycle is 700. So that means mg together is 700. So I can just put that in there. So I'm quite happy with that. And have I got the height? No, I haven't, but it tells me from point P to point Q. Now here's my opportunity to basically draw on the graph, take reading. So it started at 0 and it went up to 20. I'm showing the examiner that point Q is at 20. I'm drawing that line there. Okay, so the height must be 20. So I'm going to put this into my calculator. And I know that the answer is going to be 14,000, and standard units for energy is joules, but it's written there anyway. Two significant figures, it's already in two significant figures. So put the numbers in and be very pleased with myself that I've got too much. So I've got another calculation here now. So it says calculate the mass of cyclists. And again, as long as I'm just doing the same thing over and over again, nothing can really go wrong. So they've given me the formula. They're nice enough to do that. And it says gravitational potential energy of the cycle changes by this. What from point B to point R? What am I looking for? I'm looking for the mass. So the formula is written down. What's the first thing that I'm going to write down is mass. Have I got the GPE, the change in it? Yeah, I have. It's over there. So I'm going to put 11,250. Mass is whatever that says. Have I got G? Yeah, I have. It's 10. Have I got height? It doesn't tell me, but it says point Q to point R. Well, here's another opportunity to be reading from the graph. So point Q is 20. Point R, it tells me is 35. So I know there's a difference I worked out earlier of 15. So my change in height is going to be 15. And again, I could rearrange this in one step if I wanted to. But if I'm struggling a little bit with rearranging, I can just say M times 10 times 15 is 150. That stays the same on that side. So now I know M equals 11,250 divided by 150. So that M is going to be equal to, I'm going to put this in my calculator to find out what it is, 11250 divided by 150 is going to be equal to exactly 75. And I can put 75 in here as well. Now look how I've made sure that I've shown every single stage of my working, and I've made sure that all of my equals line up with each other, because I don't want to go wrong anywhere, and I want to make it as simple as possible for the examiner to make sure I just want these 2 marks. And now I've got. Okay, so let's have a look at the next one. Explain. So it's explain questions. I'm going to go law principle formula if I can. And what's the information they're giving me? It says the work done by cyclists between Q and R is different from the change in GPE. So earlier we've just said, oh, they kind of mix it up by saying sometimes they say work done, sometimes they say GPE, but now they're saying that they're not actually equal. So even though we know that we use them to mean they're the same thing, this is a question asking me why they're not equal. Well, when do they ever ask about this type of question? When it says, why is the total energy not the same, or something like that, is always going to be the same thing. So they've phrased it slightly differently, but I should just know this is the same 1 or 2 mark question that they always put on the end. So they're saying, why is the energy put in not the same as the output energy? What is always going to be the answer? It always has to be the same thing. So some energy is wasted as thermal to the surroundings due to friction. And then the only thing that you need to use your brain for is what's the friction between. So I'm going to say, I don't know, between air particles and the bike or the person. Or I could just say as air resistance or something like that. But if I just want to be consistent with how I'm answering it, I'll always do it. I'm just going to always do it this way. So this is a 2 mark question. I don't know which of these points the 2 marks are going to be coming from. So I don't know if it's going to be saying for wasted, is it going to be saying for thermal, is it going to be saying for surroundings, is it going to be saying to friction, is it going to be saying for what the friction is between. So I'm just going to say all of them. Every single question about energy is wasted because of this and that, just say that, and those marks are in the bag. All right, so the next one's just a 1 mark question, a content question really. And what is the key thing that stands out to me here? So it's saying lubricating. So that's the thing that they're really testing me on. Well, what do I know about lubricating? I know that it's going to decrease the friction. If it decreases the friction, it's going to decrease the wasted energy. So if it's going to decrease the wasted energy, let's have a look at which of these things it's going to apply to. So will it decrease the amount of work done against gravity? No, it's not going to do that. Is going to decrease the efficiency. What I've said is going to decrease the wasted energy, so it won't decrease the efficiency. Is it going to increase the efficiency? Yeah, it will, because if I decrease the wasted energy, I'm going to get more useful output. Increase the overall amount of energy transferred by the cyclist? No. So I only think that one thing is the correct answer, and I'm happy that therefore it's bound to be that in game. Okay, so another formula question here. So this is worth 3 marks. And again, when I see a formula question, I'm pretty much going to be thinking, thank you very much, because I'm just going to do the exact same thing and I just want these marks for free. So it says calculate the velocity. So I'm going to put V in there first. Now, obviously this one, it says V squared, so I've got to be careful with that. So I'm going to write the V squared on the end. I'll put the equals under the equals, and now I should be able to fill everything in. So have I got kinetic energy? Hopefully I have. There it is. So I can put 2,800. A half is a half. Have I got mass? Yeah, I have. Is 85. So I'm going to write 85 here. And now I can just rearrange this. And again, I can do this in stages if I want, to make sure that I don't make a mistake. So 2,800 is still 2,800. Half of 85 is 42.5, and that's going to be times V squared. So I can say V squared equals 2,800 divided by 42.5. So V squared is going to be equal to 65.88235. I'm still writing the full number off the calculator, and then I'll just take the square root of that and get the answer of 8.1167, rounded to significant figures, and the answer is going to be 8.1. So I'm pretty happy I've got the full marks for that question. Okay, so I can see the topic is electricity. And what is the thing that it's asking me for? So it says draw how it should be completed so that the current in the circuit and the voltage across the device can be measured. So the keywords are obviously going to be current and voltage, and how can I measure it? Well, what's the measuring equipment I'm going to need? And I'm going to need an ammeter for the current, and I'm going to need a voltmeter for the voltage. So what are they testing me that I know about it? Well, I should know that in order to measure the current, I need an ammeter, and an ammeter needs to go in series. So I'm putting the ammeter in series, and then that's fine, that can just be there. And the device being tested, I'm going to need a voltmeter across there in parallel. So it's just anywhere in parallel will be okay, so I can just put it here, voltmeter there. If I wanted to put it here as well, that would be fine as well. But the key thing that the examiner is testing is, do you know that ammeters measure current and they always have to be in series, voltmeters measure voltage and they always have to be in parallel. Okay, so it looks like it's my lucky day because there's a formula, and when there's a formula, I've just got some 3 marks. So I'm very happy that this is 2 marks in the bag, as long as I do everything sensibly. So units, they are the correct units. There's no milli, micro, mega, nothing like that. What am I looking for? I'm looking for the power. So I need a formula of power in there. I've been given something in terms of A, well, that's the current, and it even says it there as well. So I know there's going to be current here. And then it says something in terms of V. It doesn't say the word voltage, but I know if it's measured in V, it's going to be voltage. Is there a formula that links Pi and V? If I can't remember it, look in the formula sheet. Yeah, there is. It's P equals I times V. So I've written down the formula, and what am I looking for? Power. So write down P first. Have I got I? Yeah, I have. It's 4.8. Have I got V? Yeah, I have. It's 12. I'm going to put this into my calculator, and what is the answer that I get when I get 4.8 times 12? It is going to be 57.6, and then I round that two significant figures, 58. Job done. 2 marks in the bag. So the next one's another formula question. And again, if I just do it properly, yeah, another couple of 3 marks here. So let's have a look first, even before identifying the formula, look at the unit. So I have got a milli here. So the first thing that I'm going to do is 600 times 10 to the minus 3, because it says milli. 12 is fine, that's sorted. 7 minutes. Should it be in minutes? No, it shouldn't. It should be in seconds. So how do I get 7 minutes in seconds? I've got to multiply by 60. So I'm going to say 7 times 60 equals 420. Now everything's in proper units. So now it says use an equation select from a list of equations, and I've just got to make sure I'm identifying the equation. So I'm looking for energy transferred, so I'm going to need something with energy in there. It says current, so I'm going to need something with current. Voltage, something with volts, and it says it's in 7 minutes, and I've converted to seconds. Well, what have I worked out is time. So is there a formula that's got all of those things in there? I hope there is. Yeah, there is. It's going to be E equals V times I times T. So what am I looking for? I'm looking for energy. So I write down E first. Have I got voltage? Yeah, I have 12. Have I got current? Yeah, I have 600 times 10 to the minus 3. And look, it stands out because I converted it first to make sure I don't get excited about, oh, I found the formula and forget to do it. Have I got time? Again, I converted it first. So I'm going to write 420. Now I'm just going to put this in my calculator. So 12 times 600 times 10 to the minus 3 times 420. And my calculator tells me that that is equal to 3024. So 2 significant figures. So it's those two that I care about. So 3000. I've still got to add the 00 afterwards. So 3000 joules, and yeah, job done. Okay, so for this next one, I've got a diagram up here, and then I can see that the command word here is calculate. So if it says calculate, there's going to be a formula. I'll have to use some kind of formula calculator, obviously. And it says calculate the current in the wires to the battery when all devices are switched on. So this could be a bit confusing because I'm thinking, oh no, how am I supposed to know this? Well, actually, it's a 1 mark question. So that's already given me an indication it's pretty easy. And this isn't a formula in the formula sheet, but it's just Kirchhoff's first law that hopefully I've done my revision and I can remember what that is. That if I'm, and even if I can't, I should just be able to do it by common sense. That if I'm saying 4.8 is coming from here, 600 milliamps coming from there, 10 coming from there, 2.3 is coming from there, what am I going to have to do? I'm just going to have to add them together to get the total. Well, the only thing that stands out to me is this one here, 600 milli, because look, they've tried to trick me with the unit. So I'm going to say 600 times 10 to the minus 3. And now all I need to do is put those in the calculator and add them together. So I'm going to still write them there. So 4.8 plus 600 times 10 to the minus 3, oops, plus 10 plus 2.3. I put that in the calculator, and let's see what I get. Plus 10 plus 2.3, and the answer there is going to be 17.7. So I'll write the full answer and then always get into the habit of 2 significant figures. So that would be 18. But remember, I've still got my full answer here, just in case, just to show that I've done it properly. So what's the command word for the next question is state, which means I just know it, like I've just got to say it. So what is the key thing that they're trying to make me realize? Well, it's about overall resistance of the circuit. So what do I need to know about resistance? What are the things that I should know about, like total resistance or overall resistance? Well, I should know that if resistors are in series, that I add the total resistance up. So the total resistance is going to get bigger. So it's going to be R1 plus R2, blah, 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 all the way through. I'm just adding them up, it's going to get bigger. If they are in parallel, my total resistance is always smaller than one individual resistor. Okay, so they're the 2 things that I've got to think of. So if they're in series, the total resistance is always bigger. If they're in parallel, the total resistance is always smaller. Well, it says changes, so I know that I'm going to have to use the word increase or decrease in there. So let's have a look at the diagram now. And hopefully it should be obvious whether they're either in series or in parallel. So let's have a look. I can see that all of these things are connected in parallel. So because they're connected in parallel, that means when they're all connected, the resistance is going to be smaller. So if I get rid of one of them, well, that means the resistance is going to get bigger. So therefore, state, I'm just going to say the resistance is going to increase. Obviously, you write it out in full. Okay, so this next question is about fuses, obviously. So what's the key thing that I need to know about fuses? Well, the rule about fuses is that I know that the fuse that I use has got to be bigger than the current that needs to be carried, but it should only be a little bit bigger. I can't just go really, really big, otherwise there's no point. So what's the information I've been given? 2.3 amps. So can I use a 2 amp fuse? No, I can't, because it will just break straight away. Can I use a 5 amp fuse? Yeah, I can. So this is probably the one that I use. And then 10 amp and 13 amp are going to be too big, because the rule is I just need to use the next one up. Okay, so we can just go straight on to the next one that says explain why the wires in the battery are thicker. So then what is the thing that stands out? Well, it's going to be thicker. So that's the key piece of information. So what do I know about thicker wires, and then how can I link to the question? Well, if the wires are thicker, it means that they can carry more current. I know that they're going to have less resistance. So thicker wires have less resistance. Why does that matter? Well, if they've got less resistance, I'm going to say that less heat is going to be wasted. So less thermal energy to the surroundings, any of that. Is there anything that else that I can say? Yeah, there can be more current or more power gone to the thing if less energy is going to be wasted. I could say something about there's going to be less potential difference lost across the wires, all of those kind of things. But these are the three main ones that I've written down, because they're the way that you should be working through it. And I'm happy that, well, I've said three things, it was only a 2 mark question. I will have got the full marks for this. Okay, so let's take a look at this next question. What information have I got? Well, firstly, it's about transformers, and I shouldn't, obviously I've done my revision, I should know about that. What information have I got in the question? It says alternating current of 3 amps in the primary coil and 6 amps in the secondary coil. So is there a formula that I can use here? Is there anything that I'm looking for? It says about the size of potential difference in the secondary coil. So is there a formula that links about primary coil, secondary coil, voltage and current? Yeah, there is. The one that I should know is V1 I1 is equal to V2 I2. Okay, now if I'm more comfortable with my maths, I might be able to do this one straight away. If I'm not, well, let's just look at a technique that I can use to make it a little bit easier. So let's just put the numbers in that I've got so far. So V1 I don't know, so I'm just going to put V1. I1 I do know, it tells me, so primary means 1. So that's going to be V1 times 3 is going to be equal to V2 times 6. Okay, now I still don't really know what I'm kind of looking for here. And again, this might make it easier to spot, but if not, I can just still do something else. So what do I know about the numbers V1 and V2? Well, if I'm saying these two things are equal, I know that the number V1 must be twice as much as the number V2. Now, if I'm not too sure, I can just put some numbers in and just check to see if that works. That's what I think. Let's just see if it works. So let me just make up some numbers. So I'm going to say, I don't know, let's say that V1 is 2. So 2 times 3 is going to be equal to something times 6. That's going to be equal to 1 times 6, obviously. So then what can I say about the numbers 1 and 2? Oh, this one's going to be half as much. So I know that V2 should be half as much as my V1. Now let's try to link it to what the question says. It says, what is the current in the secondary coil compared to the primary coil then? So is there something here that says half as much? Well, this says half as much here. This says half as much. So I've got 2 halves as much. I've got to be careful. Which one is it going to be? Well, I'm looking for the size of the potential difference. So do I care about the current or do I care about the voltage? Well, I obviously care about the voltage then. So the answer has got to be D. Okay, so the next one, I've got an explain question over here. So I'm going to do the things that I'm always going to be doing. So I'm going to go law, principle, formula, if there is one. I'm going to go state the obvious. So what key piece of information have they given me, keywords, and link it to the question. Now for this question, is there a law, principle, or formula? I'm going to go formula first if there is one. Now, I mean, there is one, but it's an A-level one, so I'm not really going to use it at GCSE. It might be a bit too confusing. So I can just go, well, is there a law or principle or something like that that the examiner wants me to realise? Well, if I'm talking about causing an alternating current, what is the thing that I need to know? And I need to know that a moving magnetic field is going to induce a current or is going to induce a voltage. So a moving or a changing magnetic field is the principle that I'm going to be writing. So I'm just going to write MF for a magnetic field. Changing magnetic field will induce and because I'm just doing it at GCSE, I'm just going to say induce a current for now. Okay, so that's fine. So I've probably got a mark from that from the law, principle, formula, what's the state of the obvious? It says an alternating current. So if the current is alternating, that has a moving magnetic field. So AC has a varying or alternating magnetic field. So therefore, this will be felt by, I'm perfectly okay to say that, felt by the secondary coil. I'm just going to write SC for secondary coil. You could also say like it cuts across the secondary coil, or cuts through the secondary coil, and that's kind of the more stuff that you say at A level as well. But again, at GCSE, if you said felt by, I can't see them being too picky about that. So it cuts through the secondary coil, and then because of that, it's going to induce and again, I've kind of said earlier, induce a current. If you're doing A level, you have to say induce a voltage, which induces a current. But again, like I said for the early one, I can't imagine that GCSE is going to be too picky about that. So that would be okay. Yeah, so it's going to induce a voltage, which induces a current. So we have another calculation question, which is quite nice because I can get 3 marks as long as I'm just sensible here. So what have I got? Primary coil, so I've got the voltage here, and they're both in the proper units. And this says 600 turns. So what is the formula that's to do with turns and voltage? I know that the formula is Vp over Vs equals Np over Ns. So now I'm just going to put the numbers in that I've got. Well, what I'm putting equals in there first. What am I looking for? I'm looking for the number of turns on the secondary coil. So that's this one down here. So number of turns on the secondary coil, I'll put that in first. Now I should have everything else. Have I got primary voltage? Yeah, I have, it's 230. Have I got secondary voltage? Yeah, I have, it's 15. Have I got primary turns? Yeah, I have, it's 600. Now there's a couple of ways that you can rearrange this. But the NS is on the bottom, which makes it a little bit more difficult. So there's a trick that we've kind of done before, that if you can't rearrange it and you find it too difficult to rearrange it, one easy thing to do is you can just flip both sides upside down, and then students find it easy to rearrange it, because I want my NS to be on the top. So if I want the NS to be on the top, I've got to turn the right hand side upside down. So that goes to NS over 600. Well, if I've turned that side upside down, I've got to turn the other side upside down. So that goes to 15 over 230. Now it's a bit easy to rearrange because I can just put this up here like that, or like we've done in the other ones, I could just work out the left hand side first and say what's 15 times divided by 230. But basically I'm going to get 15 divided by 230. The whole thing is multiplied by 600, and that's going to be equal to NS. And now I can just say NS equals, and I'm going to put that in my calculator. So 15 divided by 30, and the whole thing is multiplied by 600. And then the answer I have got is 39.1304, blah, 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 blah. And I'm going to write down to 2 significant figures, or well, for this one, it's number of coils. So it should be a whole number as well. And is 2 significant figures a whole number? Yeah, it is. 39. So 39 is going to be the right answer here. Okay, so what stands out to me in this question? Well, there's a graph, obviously. So as with all graph questions, I'm not going to be happy until I get some kind of information, show the examiner that I can read the graph, I can understand or interpret the graph. Well, there's no numbers on this one, there's no units here. So I know there's nothing to do with taking an actual number and showing that I can read a number, but I still need to show I can interpret a graph. So what do I know about it? Well, there's a positive region, there's a negative region. I can see that the current's constantly changing, it's going up, down, negative, all of that. So I know it's going to be something to do with that. That's how I'm going to show that I can interpret this graph. So let's take a look at the question then. So it's a 6-mark question over here. So I should be thinking about what is the general structure for a 6-mark question. I've got to break up into parts and then talk about each part, make sure I'm doing all of that. So it says explain why the current changes in the way that's shown by the graph. Now this is something that we've been through in lessons and stuff as well. Now if I'm saying, if a graph question or a question says describe the graph, it means just say exactly what's happening. So it's going up, it's going down, blah blah, all that kind of stuff. If it says describe and explain, I need to do all of that first and then give the reason why. If it says explain, it still means describe and explain. There's no difference between explain and describe and explain when we're talking about a graph. So as soon as I've seen this thing over here, I know and I saw it's a 6-mark question, I'm going to have to break it up into first describe what's happening and then explain what's happening. And actually, they've done something that's even nicer for me here, which they wouldn't necessarily have to do. They've said talk about each point P, Q, R, S, and T, and they've put P, Q, R, S, and T on here. Now, for all graph questions, you should know yourself that you've got to break it down into the significant points. But they've been nice enough to tell me the significant points are P, Q, R, S, and T. So I'm going to make sure that I'm talking about all of those. And then the last thing it says here, you may use diagrams to help you answer. Hopefully you all know what you may use diagrams to help you answer. If it says you may use diagrams, it means there's marks available for there, which means you damn well better use a diagram. I just want to get these marks. If it gives me the option and I know there's marks available for it, well, I'm going to try to get the marks if I can. Okay, so we've already said that the explain means the describe and explain. So we can do the describe bit first, that's fine. And then we can do the explain bit after, or we can say describe P, explain P, describe Q, explain Q, and so on. Well, what's going to be easier? It doesn't really matter which way that you do it. So we can just do it, describe everything first. So what can I see that's happening at P? I can see at P, the current is 0. From P to Q, the current is going to be increasing to a maximum value. So I can say all of these things. At P, current is 0. P to Q, current increases to maximum. And like I said earlier, because I want to show the examiner I know there's a positive and a negative region, I'm going to say to max positive value. And then what's happening after that? So from Q to R it's decreasing. So Q to R, current is decreasing. That's meant to be an arrow there as well. It keeps on changing my stuff, but hopefully you're listening along and understanding. From R to S, it goes to negative, and then it goes to max negative value. And then from S to T, so R to S there, so that's the maximum negative value. And then from S to T is going back to 0. So it's increasing back to 0. Okay, so I've described this now and I've made sure I've talked about all of those different things. Now, what haven't I done? I haven't explained it yet. So I've got to say, why is the current going to be P at 0? Why is it going to be maximum at Q? And so on. So what's the topic of the question and what's the information I can see here? Well, I can see that it's to do with rotating a coil through a magnetic field. So what is the law, principle, or formula that I know in this situation? Well, the law, principle, or formula I know is that if I'm rotating a coil through a magnetic field, I know that's going to induce a voltage, which is going to induce a current. So I can just say that first of all. So rotating a coil in magnetic field induces a voltage, which induces a current. So I'm going to say induces voltage, which induces current. Okay, so I know this is the main principle that I'm applying now. Now, I'm still really stuck with this question because I can't think, well, why does that have that shape of the graph? Well, if I know that this is true, that rotating a coil in the magnetic field induces a voltage, what's going to induce more of a voltage? Well, or what's the reason why that's happening? Well, it's because, like we said on a previous question, there's going to be a changing magnetic field. So when I'm rotating it, first there's a lot of magnetic field going through it, then there's no magnetic field. Now this is where my diagram come in handy, because this is north and south. So when I've got my coil over here and it's facing that way, so the coil, so that would be like this is turning like that, so it's coming like this. My field lines always go from north to south. I've got a lot of field lines going through this. And then if I have the next stage over here, and the coil is now horizontal because I've rotated that by 90 degrees, I've not actually got any field lines going through this gap in the coil because the gap in the coil was here. So in option number 1, I've got loads of field lines going through. In option number 2, I haven't got any field lines going through. Well, that's something maybe I can say in my answer as well, but because I've drawn the diagram, remember I can get marks for drawing the diagram as well. So now let's see what's happening. So which induces the current, and that's because there's a changing magnetic field. And we've already said before about what the law, principle, or formula is. That changing magnetic field is going to induce a voltage, which is going to induce a current. So now, if I'm still stuck on this, I can't really apply it to the question. Well, let's just say what I know. So if I'm saying a changing magnetic field is going to induce a voltage, well, what's going to induce more voltage? Because somewhere I've got more current, less current. So if I want more current, I'm going to need more voltage. If I want more voltage, how would it apply to this? Well, I'd have to change the magnetic field quite a lot. I'd have to change the amount of magnetic field lines that are going through the coil. And this is where the link might be a little bit tricky. But like I said, if you're saying that if you've got this and you're just making those sensible conclusions, you're at least getting most of the marks for this question. So because I know changing my magnetic field is going to induce a voltage, I'm going to say a greater change. This must be true then, if this thing is the thing above that I said is true. A greater change through the coil will mean a greater V, which will mean a greater I. And again, I'm abbreviating, you got it right in full. Okay, so when is there going to be a greater change through the coil? Well, if I'm saying that at P it was zero, there was zero current in there, and at Q it was maximum, I know that Q must have had a really big change through the coil, P must have had barely any change through the coil, and I can just say that here again. So P has barely any change, or no change, I should say, really. Q was the one that had maximum change. And how does that relate to the diagrams that I've drawn? Well, even if I still can't figure that out, I've already got most marks for this question, hopefully now. But let's see. So if I'm at number 1 and I'm rotating this coil here, I've got all the field lines going through. If I'm rotating it, if I rotate it slightly, still basically all of those field lines are going through. So is there very much change or not? Well, no, not really. There's not very much change. So because I've labeled this 1 and 2, I can just say diagram 1, there's very little change or no change, so very small change in the magnetic flux, which is more of an A-level one because they're magnetic field lines, or magnetic field lines going through the coil. I'm just going to write like that, going through coil. Therefore, is there going to be a very big voltage? Not really. Therefore, is there going to be very big current? No. So I'm going to say, so the V is going to be very close to 0. Therefore, I is going to be very close to 0. So when the coil is exactly like that, there's going to be no current. Therefore, that's point P. Okay, so then obviously the opposite is going to be for point 2. So diagram 2, at the moment there's 0 field lines going through there. So as soon as I move it a little tiny bit, there are some field lines. Well, that's a big change from 0 to something. That's a pretty big change. So there's a big change. So there's going to be a big voltage. Therefore, there's going to be a big current. Okay, so now I've talked about why it was 0 and why it was maximum. Well, then when it's going back to R, I know it's because it's going back to being in this orientation again, but it's rotating the other way. I haven't still spoke about the negative part, so I've just got to mention why it's negative as well. Well, why would it be negative? So it's negative when the coil is facing the other way or when it's in opposite orientation. So negative when coil is in opposite orientation or facing the other way. And now I have, let's just see if I'm going to get full marks for it. So it says explain, which means describe and explain. So I went through all of that stuff and I said at P at 0, R at 0, T at 0, Q is max, S is max negative. So I've said all of those stuff, I've described it. Have I explained it? Yeah, because I've given this reason over here. I've talked about positive and negative. So I'm pretty happy that I'm going to have 6 marks now for this, which would have been a pretty difficult question, but I just made sure that I broke it down and just said what I knew. And then, yeah, even if I'm missing some stuff out, at least I'm giving myself a pretty good chance here. Okay, so we've got a formula question now. So as long as I just do the standard things, I know that I'm probably going to get full marks for this question. I just got to make sure I'm being careful that I know the kind of tricks that come up and I'm just being careful about them, don't make any mistakes. So check for the units. So kilograms, that's okay. Degrees C, I don't need to convert to Kelvin here because I've got two of them and there's a temperature change. So the conversions will cancel out for Kelvin, so that's okay. I can keep it in degrees C. Joules, kilograms, degrees C, all of that is fine. And then I've checked the units. Now, how am I going to identify the equation? Where it says calculate the amount of thermal energy, so the equation needs to have energy in there. I've been given a mass because it says kilograms mass. I've got two temperatures. I've got a change in temperature. I've got a specific heat capacity, which is C. So is there a formula with these things in there? Yeah, there is. It's going to be E equals M times C times that T. So energy equals mass times specific heat capacity times temperature change. Okay, what am I looking for? I'm looking for energy, so I'm going to write down E in there. First, have I got a mass? Yeah, I have. It's 1.41. Write that down. Specific heat capacity is 4,200. Write that down. Change in temperature. Change always means something take away something else. So 100 take away 25, which will be 75. But I can just put all of this into my calculator now. So 1.41 times 4,200 times 75. 100 take away 25, and that is going to be equal to 444,150. So I'll write the full number, always get in the habit of putting two significant figures. So here's my first two, so there's going to be something to do with that. So 4 stays the same because that number there's a 4. Then all of these will turn to 0. So the answer that I'm getting is 440,000 joules. And yeah, that is that's in joules there. So I know there's no conversions, there's no tricks. I'm pretty happy that I have got full marks in this question. And actually, I've just seen now, so it's good that I've been saying this. It says there, give your answer the appropriate number of significant figures. And I've been making the point that people forget about, or they don't notice it because they're too busy actually getting the question right. And I just kind of skim past that myself as well. But because I've got in the habit of always giving things two significant figures, I've got this mark, which otherwise I would have missed. Okay, so the next one straight after is another calculation question. So I'm just going to do the same thing. Okay, so kilograms and joules, the units are absolutely fine, so I'm happy with that. So now how do I identify the equation? Well, I'm looking for the specific latent heat of vaporization. What's the symbol for that? It's going to be Al. Is there anything that I've got in there? Well, it says something about mass in there. So I've got something about mass, and it says the thermal energy, so I'm going to have something about energy. Is there a formula that I've got to use? Yeah, it's got all of those things in there. E equals M times L. Now, there's just one thing that I've got to be careful about here, because it says the mass of the water has decreased to 1.21. So decrease to show me that it's changed. Well, what do I know about when there's a change? I know it's always something take away something else. So because I'm looking for Al, I'm going to write down Al first. Have I got E? Yeah, I have. It's 450,000. I'm writing that down. Have I got M, or the change in M? Yeah, I have, because it started off as 1.41 and went to 1.21. So I'm going to say 1.41 take away 1.21 L, and then I've just got to rearrange this in the normal way. So if I'm, like I said, if we're struggling with maths, then you can just break it down easy and do the 1.41 take away 1.21 first, which is going to give me 0.2. And then even if you were struggling first to rearrange, maybe this is a little bit easier now. So have I missed a 0? Yeah, I have. So Al is going to be equal to 450,000 divided by 0.2. So Al is equal to 225. I'll write the full number down. 225,000. Just make sure I don't miss any zeros. And still, like I said in the previous question, just make sure you're always getting the habit of rounding to two significant figures. So there's that one over here. So the first two stays the same. That 2, because the next number is a 5, will turn into a 3, and then all of those other numbers turn into a 0. So 0, 0, 0, 0, 0. So I'm going to write 23. Make sure that I've got all the zeros down. And I'm happy now that I have got full marks for this section. That's 6 marks, which is essentially 3 marks because I've just made it as simple as I possibly can. Okay, so let's take a look at this question now. So is there anything that stands out to me here? Well, the first thing that stands out, it says specific heat capacity. So I know when it says that, there's probably only going to be one thing or only going to be one formula that I'm probably going to have to use. Is there any more information? Not really. The only thing that I can see, okay, it says about boiling water and cold water. So that's some kind of indication of temperature maybe. But because it says specific heat capacity, I'm already pretty happy, pretty certain that I'm going to have to use this formula over here at some point in this question. So I'm already ready for that. Now let's have a look at what the question is saying. So firstly, it's a 6-mark question, so I should know the procedure for answering 6-mark questions. I've got to break it down into however many parts there are and then give detail for each part. Well, it's already broken down here for me, so maybe they're the two parts I'm going to need. But let's read the question properly and have a look. So it says, describe how a student can use evaporators and additional items needed to determine the specific heat capacity of aluminium. So this is kind of a nice one, I suppose, because it looks like a pretty difficult question that I don't really know what I'm doing here. Something confusing that I've never seen before, but I can see from here, look, it's a practical question. So because I know how to do practical questions, I've learned that properly. I've made sure that I'm following that same procedure. Well, this is going to be an easy place for me to get marks. So I'm a little bit more relieved now. And the other thing that I'm very happy about is that it says calculate. Well, I know what to do with calculations. So again, I know that there's going to be some formula in there. Well, even before I started, I knew it was this formula. So even if I don't know what I'm doing yet with, oh, this question is so hard, well, who cares? Let's just pick up as many marks as I can. So I know that I'm going to get some marks right in the formula. I might as well write the formula down, or it's going to give me a clue as well. Okay, after I've written the formula, what do I have to do for practical questions? After the formula, I've got to say measure this using that, measure this using that, measure this using that, and so on. Okay, so is there a way that I can measure the energy? I mean, not really. I'm not too sure about this because this is a Bunsen burner here. If it was an electric heater, I could say use a joule meter. That would be a little bit easy for me, but there's not. It's a Bunsen burner, so this is pretty hard. While I'm not going to panic, I just need to go, well, let's forget about it for now. Let's just move on and just see, get the other marks, get the easy marks first. So go for M. Can I measure M? Yeah, I can. That's easy. Measure mass using a mass balance. Obviously, write it out in full when you're doing it. You can't just abbreviate. So C, what it says in the question, that I need to calculate the specific capacity of aluminium. So I don't need to get that. That's what I'm saving for afterwards. And then over here, I've got T. So I'm going to say measure T using a thermometer. And the other thing I need to be careful about here is that it actually says change in T. So if it says change in T, I know it's always going to be something take away something else. That's what change means. Do I know what it is? I'm not too sure yet. But again, like who cares? I'm just going to get these marks first, and I can worry about all the other stuff afterwards. So now let's just have a look. I've gone through all of those things in the formula. I've given the measuring equipment and stuff like that. So I need to give some detail now. In this one, I can't say change this, measure that. It's not a relationship between this and that. So unfortunately, I'm just going to have to say anything that I can. So let's have a look if there's any clues here. So what's it telling me? It says the piece of string is tied to aluminium block, so the block can be transferred. So at some point, I know I'm going to be moving it from the boiling water to the cold water. Well, let me just go back here now and act like I knew that all along. So I've got those marks in the bag first. Now let's just act like I know what the procedure is, even if I've got no idea. So if it's going to be transferred from one place to the other, well, I've obviously got to put the block in the boiling water first. Okay, and then is there anything else that I can say about that? Well, if it's in the boiling water and it stays there, what temperatures are going to reach? It's going to reach the temperature of the surroundings. So then I know that the block will reach the temperature of the surroundings, so it will be at 100. So leave it in there until it's at 100 degrees C. Now the question told me I've got to transfer it. Well, I'm just going to act like that was my idea. So I'm going to put in here, transfer to the cold water. Now, is there anything that I know about this if I'm transferring it to cold water? Well, if I put something hot in cold water, obviously the water is going to heat up. So if it's going to heat up, there's going to be a temperature change. Well, that's what the thing I was worried about earlier that I didn't know about. Well, look, I've managed to figure it out now, so that's quite nice. So I'm going to say measure the temperature of the cold water first. So before and after putting the block in. And then how am I going to get the temperature change? I'm going to subtract them to get the temperature change. So now I'm happy that I've managed to get a temperature change in there. So because I didn't worry that, oh, I don't know, I'm not going to do the question, I didn't do that. I just did what I can. And now look, I've got the thing that I'm happy about. Now, is there anything else that I can do? Well, if I'm saying subtract to get the temperature change, I'm still pretty stuck on what I'm going to be doing now. So is there anything else that I can say that's got to be true? Well, why is the water getting heated up? It must have been because, and I'm going to show the examiner as I know this, now the energy from the block must have been transferred to the water. And if the energy from the block is transferred from the water, well, I couldn't calculate my energy before, but maybe I can now. So how do I know how much energy has been transferred from the water, well, I can calculate it. So I can say calculate energy transferred to the water by saying the mass of the water times the specific heat capacity of the water times the change in temperature of the water. Well, I can measure the mass of the water using a mass balance again. So I've got to measure the mass of the water. I know C of the water is 4,200 joules per kilogram per Kelvin, so I know that's going to be true, and I've measured this using the thermometer. So now, have I got the energy transferred to the water? Yeah, I have. Where did the energy come from? Well, it came from the block. So if the energy came from the block, I know the energy that's gone to the water must have been the energy that was lost by the block. So now, if I've got this number now, and again, I was worried about this before, but I just went through any process that I could think of, and I've managed to get it now. So now I'm just going to put that back into the formula. So then for the aluminium, or for the block, I know that E equals mc delta T. So I worked out the E, so I'll use the E of water and rearrange to get C, and I'll just move down here. Maybe there's going to be space down there a little bit. So that means the C of the block must be equal to, if you need to rearrange it in steps, then rearrange it in steps, but the C of the block should be equal to the energy of the water, or the energy increase of water that we worked out earlier, divided by the mass of the block. And then down here is going to be the change in temperature of the block. And I know what the change in temperature of the block was because it started at 100 and then it went down to whatever the cold water was at the end. So I'm going to just say that I've got that. Is there anything else that I've missed from here that I want to add in? So we've said how we're going to get the temperature change of the block by doing that subtraction again. Can I give more detail about how to measure the mass of the water? So you might want to say something like measure the mass of the empty beaker, measure the mass of the water in the beaker, and then subtract the two values, something like that. So I'm giving all of this detail for the 6-mark question, and now I'm pretty happy that this will be 6 marks for this. So yeah, this is the end of the paper now. So yeah, that's good. Well done.